So today I'll talk about application layer egress control in Kubernetes and also in VPCs in general. Surprisingly complex topic, which is of course why I decided to talk about it. And I'll explain what I mean by application layer. It means layer 7, HTTP layer, DNS layer, controlling access to a fully qualified domain name, to a domain. And I'm going to run through a lot of solutions. This is not a new problem. And solutions exist, but they have the limitations. They don't necessarily give you what you want, and I'll explain that. In fact, again, I started this topic because I saw that one of my customers just couldn't really solve the problem. I'll talk about new solutions that just came out. Since I started exploring this topic, I published an article in March. 3 new technologies came out in the Google Cloud to address this problem. I'm Joshua Fox. As you heard, I'm a senior cloud architect at DoiT. There is my email. Please contact me. One of the great things about our company is that we all have these avatars, which looks much better than me. And I work advising technology companies on the cloud, any question involving Google, Amazon, whether it's architecture, design, or crashes, bugs, problems. Whatever it is in the cloud, I advise these technology companies, and so I see a lot of interesting problems. I'm also a Google developer expert, although I'm not a Google employee, but I travel the world and talk about Google technologies. Today, though, you'll hear about both AWS and Google, and this is actually applicable to really any cloud or even on-premises as well. Just the examples I give will be from those clouds. I'm from Israel, but DoiT has people in my job, colleagues, in Ireland, Singapore, 20 different countries all over the world. We have no offices anywhere. Oh, here's the challenge that I'm going to talk about today. Locking down egress. Traffic going out of your virtual private cloud or your Kubernetes cluster. This is the threat model. This is why we want to lock down egress. Somebody could set up malware in your virtual private cloud, in your VPC, or in your Kubernetes cluster. Now that's a problem regardless. That's not what I'm going to talk about today. It does happen. So you want this additional line of defense so that this malware doesn't exfiltrate your data to the bad guys, to api.stealyourmoney.com. And so you don't want to just protect traffic going in to your systems, which is how to keep malware out in the first place, but you want this extra level of protection so that traffic cannot go out of your systems. What I'm telling you here is very basic, and we can discuss whether it's applicable, whether you really want to have this level of lockdown in any given case. Maybe that's a good question for afterwards. But this is very common, to just totally block all traffic in or out of your VPC or Kubernetes cluster. However, you cannot really block all traffic. I don't even know how it's possible unless, I don't know, you're doing batch processing and you never look at your data. You do need to allow some traffic for various scenarios. And here, we're going to talk about the scenario where your application needs to reach out to a web API. Here are some examples: api.stripe.com, graph.facebook.com, api.spotify.com. So your application does need to do this. You cannot have 100% lockdown, but you do want least viable permissions. That means you want to absolutely forbid everything except that exact traffic that you need to accomplish your goal. In this case, accessing a domain. Note the important point that the addresses that we are given are, of course, domain names. That's actually the key to the problem that we're about to encounter. And today I'm going to give our examples with the good guy, api.kadeth.io, the bad guy, api.lang.com. Anyway, we want to allow traffic to one domain, not allow traffic to another. I gave a lightning talk version of this with a Lovecraft theme a few months ago, but you won't have the Lovecraft theme overall here. Okay, so here's your application. It's running in a VPC. Egress is blocked by default, and our challenge is to allow access only to this domain, api.cadath.io. That is the fixed, well-known address of the good guys. However, traffic doesn't really work on that level. It works on the level of IP addresses. There are many levels, many layers. And that IP address is dynamic, changes. You have no idea how often it will change every 5 minutes. It usually doesn't, but it could. You cannot rely on that address at all. You cannot whitelist that address. So now we are starting to understand the challenge of why this is not simple. There are different layers in network traffic. And the different firewalls I'm going to discuss, some of them are called firewalls, some have a different name. Each works on a different layer, on a different level, and you have to understand what layer it addresses. So if you remember from back in college, don't worry if you haven't learned this, because I'm not going to get into this OSI layer model, except to present the concept of layers, which you are familiar with some of them. We're only really going to look at 2, maybe 3 of these layers right now. So most modern applications, called application layer, work on the level of HTTP, or more commonly HTTPS. And the address is expressed in the DNS system, where you look it up. So we have different names for this, including layer 7, application layer, although nowadays, of course, with web APIs, it's not really the application. It's slightly more technical, lower level. That's what it's called. FQDN, fully qualified domain name, is another concept on that layer. It means the full domain, api.cadath.io, can have those secondary parts. It's the address. And however, when you go down to a lower layer, the traffic goes over TCP usually, maybe UDP if you heard the lecture yesterday about HTTP 3. That's where the traffic is really happening. And the address that it uses is on the network layer, the IP address. So which layer are we working at? We're working on all of them. We need to translate between them, map between them. That's the hard part. As you see, there are other layers in this OSI model. We rarely even look at most of those nowadays. Well, down to the physical, there's got to be a cable somewhere or a Wi-Fi. Okay, so application layer and transport layer. This area is exciting because it is rapidly evolving. Just since March, when my customer had the problem, I decided to write an article. So much new has happened. So afterwards, I'll give a link to this slide deck, and you can read my articles, which are outdated, of course. One in association with KubeCon on this issue in Kubernetes. If you want, you can scan the QR code. And this one is more generally about networking, not just about Kubernetes. Again, it says similar things to what I'm saying now, except for the fact that it's outdated, does not include some of the newer technologies. And I gave some shorter lightning talks recently on this 10-minute talks, including a couple of Lovecraft ones on this topic in various languages. Yes, so it's exciting because it is rapidly evolving, and I will present those new technologies to you, well, towards the end of the talk, because those are the solutions that are just emerging. Now, we're going to dive into the different solutions which don't work properly. These are all mature technologies, they're fine technologies, they do what they're supposed to do. Unfortunately, they don't solve the problem here. So you might think of firewall, first thought, that's how you block traffic, right? The Google firewall, for example, or various third-party firewalls. However, these work on the basis of IP addresses only. And if you say we're going to allow access to that IP address, that could change in 5 minutes. You have no idea. It's not going to work. No, you can't do that. So forget firewall, the basic type of firewall. Wrong layer. I said it could change every 5 minutes. There are actually even more challenges on the mapping between domain layer, domain name, and IP address. So that's the Google firewall, which won't work. And now let's talk about some AWS firewall types. I'm going to say that some of them don't work, but they each do have a role and they do something useful. So later on in this talk, I'll explain how they can do something useful for this challenge. And you can also read my article about the many, many types of things that we can call a firewall in AWS. That got a tweet from Jeff Barr. I'm very proud of that. Okay, AWS security groups. I'm mentioning this here because I mentioned Google firewalls, so if you're more familiar with AWS, this is what you're more familiar with. And this can block traffic into or out of a given virtual machine or a group of virtual machines in AWS. Sounds good, doesn't work because you define the target by means of an IP address. And as you know, that just won't do it for us. So AWS Network ACL NACL Access Control List is on a broader level. It blocks an entire subnet. It controls an entire subnet. So you have your web front end, which is obviously accessible from the internet. You've got your database subnet, which is not accessible from the internet, and so on. And it's slightly different from a security group. You might even ask why these two different concepts exist. I already explained the use case. And again, it is defined in terms of IP addresses. It will not do it for you. IP addresses change is the first problem I've already mentioned. So as Heraclitus said, you cannot step in the same river twice. And if this address now, which you've allowed access to our api.cadeth.io, but in 5 minutes, maybe that will become the address of api.lang.com. Anything can happen. You might say it probably won't, but we can't do that in security. I mean, if nothing else, if the IP address of the good guy changes, then no egress will be possible to the good guy. Even worse would be if egress was possible to the bad guy, to the specific malicious API. I'm not even going to talk about DNS poisoning. That could be very difficult. Okay, so I just gave that dire tale of how you can't use a firewall or similar technologies. And now let's talk about how we would implement a hosted solution. Hosted means it runs on your own VM, your own virtual machine, and it's your responsibility to keep it running. Not necessarily a virtual machine. In fact, I'll talk about an example of how you can code this up yourself. And what would it mean to code up a solution to the problem we're talking up here? I don't recommend this. You should not be coding your own solutions. But it's very helpful to me to understand how all these solutions work, even if some of them are implemented in somewhat different ways. But when it comes down to it, this is how they all have to work. So you write a cron job or a cloud scheduler in Google, and basically a cloud cron job. And you set it to trigger every 5 minutes, however often you want. It calls a cloud function in Amazon or Lambda, or you could run it in a virtual machine, whatever you want. And that thing checks the DNS, and it finds out the IP address of the good guy, of api.cadeth.io. And then it makes a call to the firewall, Google firewall, AWS, whatever, NACL, and it sets that. It just reconfigures the firewall. And now I'm going to mention the second challenge with the mapping between domains and IP addresses, which is that there can be more than one. So up till now, I've said there's one IP address per domain, but there can be many, and your code that you just wrote has to do that. That doesn't sound too difficult. Just has to go to the firewall and update multiple. Although some of the solutions I talk about will give up if you have too many IP addresses. They say, no, more than 30, forget it, can't handle it. So this is how you would implement it yourself on a very basic solution. We still haven't run into a lot of other challenges, which would make this not really work as well as you'd like. But keep this in mind as I talk about how other solutions are implemented. Don't do it yourself. Do not. You will be responsible. Things will go wrong, there'll be bugs, it will crash. Plus, as you are about to see, this solution will not really work because there's all sorts of strange things that we didn't think about yet, and you don't want this on your head to implement it. You'll be maintaining it and improving it forever. Okay, so let's get on to some solutions that you didn't write. Squid proxy is a very old piece of open source code, very mature, reliable, it's great. Yes, that's baby Cthulhu from my earlier talk. The squid proxy can control traffic, let's say, in and out of your VPC in many ways. it's a proxy, right? But we're going to focus here, of course, on our egress control, and it will do this for you. It will check the domain, get as many addresses as needed, and it will allow access only to that domain. So here's an example of the configuration. Of course, you don't have to memorize it or really learn it, but it's just meant to show you the concept of how SQUID is structured for this. We deny all HTTP access in this configuration. But we are going to allow a whitelist, and specifically the destination domain is allowed. api.cadet.io is allowed. So that's how we've configured the SQUID proxy. So far, we've had two insurmountable problems, or surmountable problems, in connecting. I said IP addresses change, there can be more than one IP address. But there can actually be multiple hosts on a single IP address. Commonly, this occurs with shared hosting or with an API gateway. And the API gateway receives the traffic and then has to decide to which domain to send the traffic. So think about this sort of multiplexing. You ask, what is the IP address of api.cadet.io? You get that IP address. You connect to it. And now, we don't know which domain that's going to. So the API gateway has to know somehow. And the question of how it knows is the tricky part. Because on that layer 5, there is no indication of domain, doesn't know about domain, domain's not there. It just, I would say there's no way to distinguish. You'll see what the way is. It's a bit of a hack, but think about that. That's on the traffic level we're talking about. It's absolutely, there's just a request to that IP address, that's all. So the solution is called server name indication. This is relatively newer, still 5-10 years old, but used to be something older called SAN. In any case, SNI is the solution to this problem of knowing which server to go to. Okay, hope this is new and interesting to you. It was to me, although I have long experience, but there are so many deep secrets in these protocols. So this is how the flow happens with HTTPS. There is a host header in HTTP. And if we can look at that, then we can easily distinguish the two domains. So the traffic comes in to an IP address, but we look at the headers and we're ready to go. Unfortunately, HTTPS is used, or should be used almost universally, on the web. And so we cannot look at the host header. The API gateway cannot look, or whatever, cannot look, whatever system is doing this filtering cannot look at that host header. So here's how we do it. We send this encrypted TLS with a little indication in the TCP packet of the domain. Think about this as a sort of a violation, because it's sneaking in a higher level information on a lower level. And in layered abstractions, you're not supposed to do that. Okay, and now the other side is able to send back a TLS certificate, and we're ready to go in the usual way. We can continue from here directing traffic to the domain. There's something even beyond that, which is to even encrypt that indication so that no one knows which domain you're going to. And this involves getting a public key from DNS and then to encrypt even SNI. In order to get the public key from the DNS, you better do an encrypted DNS lookup. Otherwise, that very first lookup too will be exposed. So it's getting complicated here. And luckily, the solutions can handle this. SQUID has got something called SSL bump, peel, and splice. Again, don't memorize the text. It's just pointing out that it's able to look at the SNI, and it doesn't even have to decrypt the traffic in full. Unless it's encrypted SNI, different story. So no decryption needed of the SNI. SQUID proxy is open source, but there are commercial alternatives. I'm not familiar with them, but there's a lot. I'm just mentioning a couple of famous ones here. All that was about hosted solutions, which you should not be using, because when you run SQUID proxy on a VM, that VM can crash. Think about it. It's taking all the traffic from your virtual private cloud, all of it, through that one little virtual machine. And maybe that VM can't handle the load. Or maybe there's a bug or whatever it is, and it goes down, all your traffic goes down. So you have to put up multiple VMs, and then you have to cluster SQUID, which is possible but challenging. So you don't have to be responsible for that. I wouldn't do it. Instead, you want to use services. So here are some AWS services. AWS Network Firewall is a higher level firewall going beyond what I mentioned earlier, NACL and security group. And it's typically used by large organizations that have merged. Let's say a bank has bought a number of smaller banks, got all these networks, and they can't control them all. So the AWS Network Firewall controls them all together, very expensive, and the multi-network control is not what I'm focusing on here, but I'm focusing on the fact that it has these advanced capabilities, including distinguishing between domains. And yes, it will do SNI, and it will peek into the domains. So you could use that. Again, just a bit of configuration code to remind us what it can do. It can handle HTTPS, as you see here. And this is an allow list that we've configured. Here's another type of firewall in AWS, the Route 53 DNS firewall. So if you're playing around with protocols in your mind, you're thinking, how can I control? This is a completely different angle. This does not control egress. It controls the ability to look up the IP address. So it says any entity inside the VPC can discover, can learn, can ask the IP address for ap.cadeth.io, but not for anything else. And therefore, it won't be able to contact them, but it does, if somehow, mysteriously, that malware learns the IP address of the bad guy, there's no control at all. It doesn't actually control the traffic, just the lookup. So I don't really think of that as egress control, but it's a nice, different angle to look at. All right, that was AWS. I am a multi-cloud advisor, so let's talk about some Google solutions. The Google Secure Web Proxy has just been coming out in the last 6 months in alpha, and just recently it came out generally available. You may have seen it mentioned as Google Secure Web Gateway. That was just a branding change. This is the name you'll see it under now. And one way it can work is by decrypting traffic. You give it a certificate to play the role of the entity inside the VPC. It decrypts, and of course, once it can do that, then it's a lot less challenging. The challenges I mentioned are less of a problem, although it can also do SNI. Here I'm just giving a brief overview, but if you want details, please see the article by my colleague, Chimbu Chinadurai, and he went down deep into it. He also wrote a couple other articles I'll reference as well. These are the first articles on the topic. The talk you're hearing now is the first ever in the world by anyone, including a Googler, on these products I'm going to mention soon. I'm actually shocked at how little Google markets its own products. So there you go, you get it first. And the secure web proxy is, think of it as a virtual machine. Think of it as somewhere halfway between a service and hosted, which is to say it's a managed virtual machine. It's on Google's responsibility. But conceptually, when you see how it's set up, you are working on a specific instance, as opposed to true software as a service, which happens somewhere out there in cloud land. And that's part of the reason might be VPC security. They want to get it deeply connected into your network. Because if you see here, it has the option of decrypting your traffic, and that might sound a little bit dangerous. Do you want a man in the middle? Well, you could argue that that's a good reason not to use it. You shouldn't be decrypting traffic anywhere. It should be end-to-end. But on the other hand, because it lives in your VPC, under your control, you can say, well, if I have bad security, I'm doomed anyway, so it's okay. Another new Google product is called FQDN Firewall Objects. So a few minutes ago, I told you that the firewall does not support FQDN. It didn't, but now it does. So there you go. You can now configure it to support, to say, here's a fully qualified domain name, and you can allow traffic to that, not another. It checks every 30 seconds. It's interesting to see that in the documentation. I was saying earlier, 5 minutes, I don't know how frequently you should check, but it's interesting to see that when I told you earlier how you would implement it, They did more or less the same thing. This means that if the address changes, you could have problems for 30 seconds. I don't know, is that okay? But anyway, that's how it does that. The FQDN firewall objects are cheaper than a secure web proxy because there's no virtual machine. It's just part of that firewall which does live there, somewhere out there in the cloud. You pay for the service, not for the resources. It's cheaper, but there's no SNI. It's not as sophisticated as some of the solutions I'm talking to you about now. New, just, oh, an article by my colleague Chimbu, all the juicy details, only article out there as far as I know. I've now reviewed some solutions for AWS and Google. I told you what they do and what they don't do, but there's a very important topic about what they don't do, and that is Kubernetes. And I built this talk as Kubernetes because that was the target of my customer who wanted to control traffic out of a Kubernetes cluster. And, well, it was challenging to impossible for her to do that. So you know that Kubernetes is another cloud on top of the cloud. That's how I think about it. When I first learned about Kubernetes, I learned there were nodes. Well, isn't a node just a virtual machine? Well, it doesn't have to be, not exactly. I don't know. It's basically a virtual machine. And you learn about other things, like an Egress. Isn't that just a type of external load balancer? Yes, sort of. There's a mapping between Kubernetes objects and cloud objects. It's as if they layered another standardized set of concepts over the Google Cloud or over any other cloud. And in many cases, it's nearly one-to-one, as in the examples I gave of nodes. But in other cases, it gets complicated. For example, when people ask me, you know, how much does it cost me to run the pod? Or how much does it cost me to run the pods in a namespace? And I'll say, we can look into, there are tools for looking into that. This has nothing to do with your nodes, because you could have pods from a single namespace in 2 nodes, or pods from multiple namespaces in 1 node. It's a completely different, in this aspect, it's a completely different world where it doesn't even map to one-to-one. So all the solutions I've told you now do not recognize the specific concepts of Kubernetes, and therefore they won't do for some of these use cases, which I'm about to tell you. For example, what if you have a cluster, that's a grape cluster, with different namespaces. Those are pods, like peas in the pod, and front-end namespace, shopping cart namespace, and for security, you've created a separate namespace for connecting to APIs. Perhaps all API connections are channeled through those pods in that namespace. And you want to allow egress only from that namespace, not from the others. So there's no way anything I've told you before now can even know what namespace the traffic is coming out of. And therefore, you could use them, but they wouldn't be able to distinguish one namespace from another. That's one use case. Another is labels. Maybe you've decided to structure in a different way. You have your different namespaces. In our case, let's say that we have 3 namespaces: purchase, authentication, and refunds. And there are also pods in each one of these 3 namespaces. So you've put a label on 2 different pods. It doesn't matter. They happen to be in 2 different namespaces. And that's because these 2 involve finance. That's because they need to contact a finance API, Stripe, whatever, API.payment.co, and you want only the ones with this label and not with the other label to reach out. Again, completely impossible with the solutions I mentioned to you up to now. Now, you may be thinking, Kubernetes Network Policy. Excellent tool for controlling traffic. That's what it exists for. That is the solution in Kubernetes. And nope, it doesn't work. Unfortunately, it will only allow you to block access to a given IP address, which we already said doesn't work, or a range of IP addresses. That's not going to do it for you. And therefore, we need to look for other solutions that are not built in to the Kubernetes standard. So here's one solution. There are solutions. Cilium. Cilium is a eBPF-based networking layer. We actually had a lecture on that first day of the conference. And it completely controls, should I say, everything on each host. It's kernel adjacent. It's almost part of the kernel, basically. So this is very deep, and as we saw in the lecture, it can do monitoring, but it can also do security, blocking, certain types of traffic, network traffic, and many, many other things. So it's a powerful tool, and you can install it in your cluster. And once you have Cilium, you can use a Cilium network policy, which is not a Kubernetes network policy. It's a new type of object within the Kubernetes world, despite the similarity of the names. And there's two types. One is Cilium network policy. The other is Cilium cluster-wide network policy. The reason for that is not too deep. It's just that in Kubernetes, most objects have to exist in a namespace. A pod is in a namespace. That's it. Not just pods. Deployments, services, many other concepts have to be in this namespace. But if you want to define things that work across the entire Kubernetes cluster, it's a different category of things, service accounts, et cetera, that have to work across the whole cluster. So there's this different thing called the Cilium cluster-wide network policy. You might want to use the Cilium network policy to allow access from a specific namespace, as I mentioned the use case earlier, or cluster-wide network policy if you want to use labels, or in some other way you want to control access from the whole cluster. This does support SNI. It's very powerful. Does a lot of things I'm not going to mention now. Here's an example of the configuration. There's a clause not mentioned here that blocks egress from all other pods, from all pods, and this just shows the exception. And as you see here, you can match a name of FQDN on the last line of the code. Here I've given api.cadet.io, but you can use wildcard. You can also use wildcards in many of the configuration examples I showed earlier. Those are just short examples. So you could use an asterisk, for example. And yeah, that's good. That does it for us. So you know what cilia are, right? They're these little hair-like objects in your intestines, or maybe in other parts of the body too. It's pretty gross looking. So I think that's symbolic of something, I'm not sure what. But the customer I was helping had 2 minutes left? Yeah, the customer I was helping was dealing with terrible bugs in Cilium. And Cilium was actually turned out was swallowing an error caused by something else. It is overkill. Istio is a service mesh. That means that it controls traffic in many ways, monitoring, routing, testing, but you can also control traffic to a service that is not in your cluster, obviously. This is our external API. It is a thing which is, unlike everything else in Istio, this thing is not in your cluster. And once we defined it, we can allow or deny access to it, whatever we want. So that's a solution. Yes, it supports SNI. Why not Istio? Same reason as Cilium, it's overkill. This is a total service layer over your existing Kubernetes services. It has its value, but I wouldn't recommend it for just this one little thing. Now, luckily, Kubernetes came out with, Google came out with FQDN, Kubernetes Network Policies, only with the new data plane v2. And here you can define a FQDN in a plain old Kubernetes policy, just what we always wanted. This just came out a couple of months ago. Again, my colleague Chimbu wrote an article on this. There is, however, a problem with this final point in our long journey from solutions that didn't work to a standardized solution that's part of Kubernetes, which is not standard. So you can only use that in GKE. However, there is a committee, part of the Kubernetes project, not in a smoke-filled room, they're distributed all over the internet, called the Special Interest Group Networking. They're working on extending the Kubernetes network policy so that not only Google, but all others will have this support. Any standard Kubernetes cluster will be able to do this. So to briefly review the techniques, Squid is mature, but you have to manage it yourself. Level 7 firewall is a service, whether from Amazon or Google. It's as a service, you don't have to manage it. We're still not in Kubernetes land. Cilium and Istio do what we want, but they're overpowered. And standard Kubernetes Network Policies are great, but don't exist yet. Kubernetes Network Policies in Google Kubernetes Engine do exist. So those are the disadvantages and advantages. You can see my sites bit.ly egress.kubernetes. And as mentioned, we're hiring. Come work with me and advise cloud customers and fly around the world and give talks and SREcon. And I'd like to hand it over to you for questions.